My talk is going to be about utilizing the various Zabbix protocols to implement new functionality or to complement existing features in Zabbix without introducing maintenance nightmares in terms of maintaining patches and other stuff. Who are we? We are an administrative region. Does anybody knows what an administrative region is? No? It's a sub-national administrative unit. I think France, Belgium, and other countries have implemented the same government structure. Our prime responsibility is governing healthcare institutions, meaning we provide, manage, and run hospitals, treatment centers, psychiatric wards, and other healthcare related stuff. I work within the IT department, and we provide anything from basic infrastructure needs, networking, voice over IP, servers, all the way to application development, application management, deployment, product management, project management, all sorts of different related technologies. Denmark is divided into 5 different regions, and we represent the tiny red dot. Some facts: we are catering a population of 1.2 million citizens, and we are covering roughly 12,000 square kilometers, 14 large hospitals, and a growing number of smaller institutions. As a company, we have 26,000 employees, and we are using Zabbix for monitoring of almost everything except network. We are currently monitoring roughly 1,700 hosts, which is around, we think, 90% of our install base at the moment. We are still finding new machines on a weekly basis that we didn't know existed. We are pushing 1,500 new values per second and have roughly 140,000 items running on Zabbix today. We have one server, a number of proxies, and luckily we've been able to migrate our MySQL instances to running on Fusion IO. So I will no longer have to worry about doing partitioning and other fun stuff. We currently have 900 different applications in production. Sometimes we even have up to 4 or 5 versions of the same category of applications. I think we currently have 4 or 5 different X-ray imaging systems in production, because many of our customers can't agree on using the same product from the same vendor. We are very lucky in terms of still having production environments running Windows NT 3.5 and upwards. Basically, if it was written as an operating system, we have it somewhere. We even have OS2 in production. Basically, we're sitting on top of a gigantic pile of technical debt that we are monitoring using Zabbix. We have 4 or 5 different flavors of Linux. We have AIX, we have Solaris. We have storage from Dell, HP, IBM, NetApp, EMC. We have a lot of different appliance boxes, which we also monitor using Zabbix. My relatively short agenda. I would like to provide some background information into why we are doing what we are doing. I will briefly touch upon the various Zabbix protocols and give 4 examples about how we implemented needed functionality by emulating the agent or server protocols. One of our largest issues is system management. We have so many machines, so many different operating systems. even though we have an Active Directory structure in place, we still have a number of legacy domains. We have issues with cross-domain trust. Rolling out an update to our Zabbix agent usually takes a couple of months. We can hit 1,000 machines within 2 days. The rest is manual labor. Trying to track down somebody who knows what the hell we could use to log into this box with. And if everything else breaks, we still have other means, such as using various tools from the internet to gain access to machines we don't have credentials for. We would like to be able to manage our infrastructure without having to compromise. Some things are very easily done in Zabbix, but Zabbix is not the right hammer for every type of nail. We need scalability because we can easily come into a situation where we need to process 10,000 metrics a second. And we want architectural freedom. And this is perhaps one of the most defining guidelines for the way we're doing things. We are very much against directly integrating vendor-supplied systems with each other, because that prohibits us from changing our infrastructure without having to implicate a number of different users, departments, vendors, etc. Everything that we are doing against our Zabbix installation or the data that Zabbix collects is done against the middleware software that we have written, because that buys us a number of architectural, or a good portion of architectural freedom. We would like to avoid maintenance nightmares. It's the easiest thing in the world to write a script and use it as a user parameter, but maintaining that script in our particular case is a freaking nightmare. That's unlikely to happen. And I mean, these are our problems, so your mileage may vary. There are documented protocols in place for simulating almost every aspect of a Zabbix installation. Agent, both active and passive, server, proxy, Java gateway. In most basic cases, you could probably do just fine by using Zabbix get and Zabbix sender. But like I hinted in the comment to one of the talks yesterday, shelling out of something like the JVM or other high-level languages to execute a shell command or a command is simply introducing so much overhead that it will kill performance at some point. There are multiple versions of the API. I think Alexi was making Zabbix Enterprise-like with Zabbix 1.4. I think that's when the XML API started. Thankfully, JSON seems to be the recommended way of doing things in newer versions. Older versions are still supported, so in the most basic way, you can actually netcat or telnet to an agent port, type agent.ping, type enter, and you get your value back. The documents itself are, in fact, very well documented on the wiki today. Links to different implementations in different languages. Basically, it's a header, data link, and data. But we can take a look at that later. There's lots of sample code in Python, Ruby, PHP. I even stumbled across some shell scripts doing funky things. So it should be relatively easy to get going. If we take my first example, we run a lot of Windows, and we use the built-in services item to detect if services that are set to automatic start stopped running. Our next logical conclusion was if we can detect that, we should probably just try to start the various services a number of times before going out and alerting our staff. That proved to be somewhat problematic, because if you have more than one service that's failed, this item is going to give you a list with one service name per line. And this is not something that you can easily feed to the existing Windows tools like sc.exit for starting services. You could probably just have deployed a PowerShell script or VB script with your agent, give them that data, have them loop that, do something. But again, that's something we would rather not have to maintain that. So what we've done, we've written a single controlled version script which runs on the main Zabbix server itself, which gets the list of services, loops over them, and actually executes a command on the agent. And it's a fairly simple example. There's a lot of logic in here. The interesting thing and the main stuff is this. We're opening a TCP port and we're actually just writing system.run, yada, 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 service name, enter, boom, service goes and starts. How many people in here have very aggressive update times for the items? Are there any people in here who update items every 5 seconds? 10 seconds? We are very protective about our Zabbix environment and also about the potential impact that aggressive polling can have on our agents. So we usually do not go below 1 minute. But sometimes, especially when stuff starts being erratic, you would like to know or have at least a real-time view of what the hell is going on. Usually that means that you would log into the server using whatever means you have, start top, dstat, perfmon, whatever, to take a look at what the hell is happening. But we figured we would much rather have to do that from within Zabbix itself. So we did a small extension of our Zabbix specific REST API, which lets you ask for specifically, we duplicate the group, host, and item triplet that everybody should be familiar with. We pull that data out of the API every 15 minutes, cache that in Redis, and populate a list so that you can hit a page, you can select, I want this group, this server, this item, and it draws a real-time graph, or at least as real-time as we can make it. Because of our network topologies, we usually have a delay of 3 seconds. This data is not stored in Zabbix. It's kept in the browser and in the browser alone. Meaning if you kill your browser window, the data is gone because you usually don't need that. There are a couple of buttons so that you can export the data you collected to PDF or CSV or whatever format you would like. In the version that sits in my master branch, it's actually possible to instantiate multiple graphs, selecting multiple servers to do correlation on the fly between different servers, let's say your application server and the SQL server, to look at if there's some sort of coherence between the metrics you're looking at. A small snippet of our Sinatra-powered REST API. We take some input, collect data. The collect data method actually just connects to the agent and asks for whatever data we want. This naturally only works for numerical items, so we actually filter away any item that's not numerical in the drop-down list. And it produces rather nice graphs, which you can format in different ways. And this is something that our ops team has been really grateful about. So we're most likely to expand this line of thinking in terms of enabling running remote top, remote task list, remote whatever, more or less directly from within the Zabbix interface. This is not functionality that we are hard coding into Zabbix. We would much rather provide links so that you can actually jump out of the Zabbix installation and into a different tool or onto a different page. Because maintaining patches to the front end over a longer period of time is too, it needs too much manpower. For the next two examples, we need to briefly discuss a bit of shared infrastructure. We have a distributed message queue, which is called Rescue. It's a product that comes out of GitHub. It's really neat. If you don't know it, and if you're into Ruby, check it out. There's a PHP version of it as well. Basically, it allows you to stuff objects into a queue and fetch them and process them later. It supports multiple queues. It has very elegant failure handling because there's a special queue called failure where problematic jobs are dropped so you can review them manually, make code changes if that's what you need. The various queues are drained by worker processes. There are rake tasks to instantiate anything from 1 to 50 or 500 workers depending on how much you need. And you can run those workers distributed. In our environment, we have a queue for each proxy and the Zabbix server itself. And we have a number of workers running on the Zabbix server and the respective proxies. How many people here are familiar with mCollective? This is basically an inspiration for trying to do this using the Zabbix agent. As I've mentioned, I'm sure a couple of times, our main issue is system management, meaning we do not want to deploy a lot of agents on our machines that we then need to maintain. So once we get an agent out there, we would like to utilize that as much as we can. The basic thinking here is we would like to ask questions and get some answers in a relatively short amount of time. We could state questions like, how many Windows 2003 boxes do we have that do not have this patch installed? We can run this across our 1700 machines and have a definitive report within a couple of minutes. We could do queries like, we want to know what software we have installed, what versions we have installed. Please remove the duplicates and give me a count per host. We have predefined reports, and we have the ability to do ad hoc queries of items and a couple of user parameters that we have deployed. Basically, those jobs get deployed using a very, very simple UI or script. They are powered by either built-in items or user parameters. Our internal REST API looks up the host in question and figures out, is this host monitored by a proxy or not? And puts a job into the respective queue for that respective proxy, so that we actually try to locate or fetch the data as close to our machines as possible. And then we have worker processes on each proxy actually processing the jobs and sending data back into our data stores. We have multiple ones. For predefined reporting, we tend to stick to traditional databases because we have a relatively well-defined schema. All the ad hoc stuff actually gets dumped into Elasticsearch because we need something that's schemaless. And Elasticsearch is something that we are familiar with already. Rescue has a very nice UI, by the way, which lists the number of queues you are having, how many workers are working, what they are working on, how many failed objects you have. So it's fairly enjoyable to use in daily life. We have a number of jobs queued. We have no workers running because I killed them all because they drained the queue so quickly that I couldn't take a screenshot fast enough. But all in all, it's a solution that we are fairly happy with. I've mentioned a couple of times that we have an internal API. This relates directly back to our statement about architectural freedom. We own Zabbix as a tool, but we do not own the data that Zabbix produces. meaning that data should be available to every interested party in our organization. We're feeding asset management. We are doing quality control in terms of how much impact did a particular change request have in reality, in terms of were the estimates about how much impact this change has real or not. And we are using this REST API, which basically emulates almost all of the various GET functionality in Zabbix, and use that to interface with our business, because this gives us the freedom to update Zabbix, or should something else happen, integrate other tools into the pipeline, or perhaps even switch Zabbix completely without impacting our entire business, external vendors, etc. Any questions so far? Good. The last example I would like to talk about is monitoring of applications. We were having a need to be able to collect various metrics from a lot of different applications, written in a ton of different languages, but we basically wanted a way to run metric collection in production. Meaning that we could track how many SQL statements are we issuing, what's the average response time of a certain type of query, how many users are logged on, how much resources are getting consumed by a particular job, anything of that nature. And we needed this to be fairly versatile, but first and foremost, it must be easy to consume for various programmers to integrate that into applications. We must incur as little overhead or latency to the application that's using our API. And we also needed scalability. So, we built a tiny API which can consume JSON or XML messages because we're enterprise. And we export 3 different transport mechanisms. We can accept data using UDP, TCP, or HTTP. UDP is rather perfect for metric collection. It doesn't generate an enormous overhead on the application to send a single UDP package. If that packet should get lost, who cares? It's one metric out of thousands. TCP, on the other hand, is perfect for signaling stuff that you care about. Let's say you want to track exceptions in your code, and you actually want a sort of guarantee that once you have sent that data to our API, it's actually there. So that you can process it, we can alert on this, etc. HTTP is perfect for front-end stuff that cannot easily open sockets or integrate into existing websites using AJAX requests, stuff like that. This reuses our existing rescue implementation. The important thing to notice is that the sending and receiving operations are completely disconnected. Meaning once you have sent data into our API, it gets put in a queue and then later drained and pushed into Zabbix by using a Ruby implementation of the Zabbix sender protocol. This means that even if we have a misbehaving application that hammers us with 10,000 metrics a second, we are not DDoSing our own infrastructure. This API is part of the REST API jar that we deploy to all our proxies. So again, you can submit data as local to your node as possible. The code in itself is fairly simple. This is the client perspective of the UDP API. You're basically generating a JSON string and sending that. There is an opportunity to actually embed a timestamp into this JSON structure, which will be adhered by the Zabbix server, meaning that you can batch operations, like say you batch metrics tracking or tracking metrics through a period of time And then when the load on your application drops, you can then utilize that moment to push your metrics to the API. This is actually all it takes to implement the server side of our UDP API. It's fairly simple, fairly straightforward Ruby code. We are using the event machine framework to be able to do a lot of async handling. We have tested our proxy deployment, and each proxy is able to sustain in the vicinity of 15,000 requests per second, which is more than we need at the moment. The implementation of the Zabbix sender protocol is at least partly here. It's a version string, data length, and actual data, some padding. There's really not much to it. All in all, we have been running this in small scale production at the moment, and we are continuing to advocating this technology not only internally but also to the different vendors that we're working with, to see if this is something that we can persuade them to put into their applications, so that we can have. We basically want to have the same data to look at as different vendors, so that we can reach the same conclusions, which is fairly difficult if you have different data points. Carrying on the tradition from last year, there were a number of wish lists on the end of people's talks. I have a number of them. One of them is in-band timeout signaling, because it's a major pain that there's a hard-coded value of 30 seconds that you cannot cross unless you patch your infrastructure. It's totally fine for everyday item collection that you have a hard-coded timeout, but I would like to be able to specify a timeout in my item definition saying that this particular item may run for 1 minute, 2 minutes, or 5 minutes. Second to that, I would love to see conditional logic in the Zabbix server, meaning that a basic if-else-then structure which would allow us, let's say, to utilize low-level discovery to say, okay, if you find this, do this. If you discover this application, link this template, otherwise link something else. That would be tremendously helpful. And please finish the goddamn API. Pavels. I mean, one thing that should be clear after this conference is the enterprise part in Zabbix comes from the ability to do integrations, because that is a primary requirement in larger environments. The API is paramount for those integrations. And stuff like the Trends API, the Trends API isn't even there. There is still stuff missing. And even the web front-end developers are not eating their own dog food because they still rely heavily on different forms of database transactions. And one thing that really got me rambling last week, because it broke a bunch of my code, please do something so that we can automatically enable automatic inventory mode automatically, or something. Because right now, every time you add a host, you have to actually click the goddamn button. I mean, you could script your way out of this. We've actually done that. We're actually detecting, because we're exporting all our inventory data gets exported to our asset management software. And the thing is, if automatic inventory isn't turned on, a part of the data structure is actually missing. So we detect that, we try to correct that, but it would still be awesome to have something in the global configuration that says, please do this for every single host we add automatically. That's one less script to maintain. So now I'm going to shut up.
Well, you ranted about the API and some other things. Is there any Zabbix protocol that you would like to rant about? Like a protocol that you dislike? Chance, use it.
How much time do I have?
You want to be honest?
Yeah. I actually think that re-implementing Zabbix Get and Zabbix Sender in various types of software, because we have a PHP version which is deprecated, because all our new stuff is done in Ruby, has actually been a fairly pleasant experience. The protocols are fairly simple to work with. It's a joy to see that XML seems to be deprecated as well in a more larger and larger scale. So all in all, it's been fairly easy. Developing the application monitoring API, which kickstarted the whole process of rewriting Zabbix Get and Zabbix Sender into something that's more manageable for us, took 2 days. With a bit of Googling, a bit of research, spying a bit on Nelson's code. So all in all, that was a fairly easy and enjoyable experience.
Any more questions?
I didn't quite understood how you're using Q and Zabbix for how that's where is exactly the Q when agent takes the data.
Yeah, the thing is, if we take our graphing tool, we are actually it's an AJAX request which calls our internal REST API, which then asks data from the agent and returns that in the AJAX request. The host interrogation and the application monitoring API are disconnected by use of message queue, meaning we have a producer, which is a internal UI where you can select a predefined job or write your own small query to execute. And these get put into the queue directly and then processed by workers which reside on each proxy without having anything to do with the Zabbix server at all. It's just utilizing the API to populate some select boxes, filtering out non-numerical data, stuff like that.
Thanks.